So hi, everybody. First of all, thanks to the organizers for this nice opportunity. I'll be discussing data visualization with my favorite plotting library in Python, which is called Bokeh, and which I think most of you don't use often. But that is about to change after this presentation, hopefully. So first of all, the motivation. It's pretty straightforward. I would like at the end of this presentation for people to know, to enjoy, and most of all to use this amazing library. And as a disclaimer, I'm not involved in its development in any way. This tool doesn't seem very popular in high energy physics. Actually, in the beginning of the session, people were listing their favorite packages, and matplotlib appeared, but Bokeh didn't. However, it's used in LHCb, and it was also mentioned by the PyHEP Software Foundation, but it was quickly dismissed, although the arguments they used there are quite outdated now. And as other plotting alternatives, Bokeh is completely shadowed by matplotlib. And this takes me to the second item in the motivation, which is, in my opinion, Bokeh code is, when compared to matplotlib, more readable, is easier to write without always going back to the documentation, which in the case of matplotlib is quite unreliable. And it gives very nice interactive plots completely for free. And then it allows you to build very complex dashboard visualizations with interactions with a bit more effort, but not too much. And that's why it's so powerful. However, matplotlib is still more popular because, first of all, it's older and then more mature, and it has more features than current alternatives. And people have the tendency to resist change. And finally, because when you look for examples in Stack Overflow, you get an histogram, a plot like this, which is comparing how many questions we posted on Stack Overflow using different plotting libraries, and matplotlib completely dominates all the available options. And some of them are quite nice. Bokeh here appears in second, but with a huge difference to the first. And I did this plot already using Bokeh, so you can see already how easy it is to plot stuff and how nice it looks. I'm a bit biased, but you get immediately some interaction for free without actually specifying it. So let's move forward and go for some basic plotting. So first of all, we're going to import some very simple data, dummy data. On here, we're going to import data to perform a line plot. And in the bottom, some data for histogram, which are probably the two most common kinds of plots we do on a day-to-day basis. And how would we do this with matplotlib? Everyone is aware. You have to create a figure object. Then you create an axis, and you add a subplot to this axis, which is quite interesting because we are only creating one plot, but still you have to create a subplot. And then if you want to change some property, you have to use setters. And if you're paying attention to the previous talk, you know now that Python has very nice properties that can be used instead. And for instance, if you want to set the title of your plot, instead of applying it to figure, which would make more sense in my opinion, you have to use the PLT, because if you use it instead with figure, you just get an error. So this simply doesn't work, which is a bit counterintuitive. Then when you try to plot stuff, you call a plotting function. What is this plotting? I have no idea. I only know because I named my data set in a meaningful way. This could be plotting anything. It's actually plotting the line. And then you call a scatter plot on top of this to get the markers. Note that actually the plotting line is called before the scatter plot, but it appears on top of the markers, which again doesn't make much sense, and I really don't know why this happens. Okay, then regarding histograms, there are many ways of doing that because matplotlib has two major APIs. So you can do it as in the left, which is very straightforward. I give that. But on the right, you can do again the same kind of thing with subplots, which is really not intuitive. And I think this, the fact that you can do stuff in many different ways gets a bit confusing, especially when you're dealing with figure and axis objects. So to recap, I think matplotlib is a bit hard to use without always going back to the documentation. However, it's more mature and complete. And there are very nice wrappers built on top of it, such as PyHEP or Boost histogram. But unless what you want to do only exists in matplotlib, I would really suggest to use Bokeh. So how would you do Bokeh, the same plots, but in Bokeh? Bokeh, its main idea is to be built around glyphs. And it relies on a layered approach where you start by drawing your figure and then you apply layers of glyphs on top of it. So first you import what you need. For instance, here we are outputting a notebook, but if you want to output a standalone HTML file, you would call output file instead with a specific name. And then let's try to do the line plot, which is much more intuitive in my opinion. You start by defining a figure, which is empty, so it has nothing in it. Then you define some options, which are assigned directly to the objects you're plotting. And then you plot in order the several layers that you're considering. In this case, the first layer would be a circle. Note that it's not a scatter, although that's also available. Instead, you plot the markers directly, so you know what you're plotting. And then you plot a line. And so when you run this, you get the plot that you're already seeing. Here, if you shift the order of the calls, then this actually makes sense. So the line here appears below the rest. So I think this is very straightforward. If instead you want to do a histogram, here it's a bit different because Bokeh doesn't perform any data processing, almost no data processing at all. And so there are no histogram functions as in Matplotlib. Instead, you have to think of a histogram as a group of glyphs, in this case, vertical bars or also quads, which are glyphs with 4 sides. And so you would build an histogram in this way. You would first define again the figure, an empty figure. And then on top, you'd call the quad glyph, which on top will have the value of the counts of the histograms. In the bottom will be 0. And on the left and on the right, we'll have the values corresponding to the edges of the histogram. And then you build the histogram. Just to show you that the figure is really empty, if I comment this line here, you'll get an empty figure and a warning from Bokeh. Simple as that. So Bokeh properties are much easier to set, in my opinion, again. If you want to change something that is related to the figure, you change it to your figure object. And if you want to change some property of the glyphs, you actually refer directly to the glyph, and so on and so forth. And it's very customizable. You can do many operations like this one. If you want to search for a specific thing in Bokeh, you can either look into the documentation or do something like this or similar. You can inspect one of many Bokeh models, such as axis, but also title, legend, toolbar, and so on and so forth, and then check what's available for you to use. Of course, I've been saying that this is great, but not everything is perfect. In general, I would draw your attention to the last point, which is currently there's no support for inset plots, which are the plots inside plots. This, I think, is the major drawback of Bokeh currently, but it's a current feature request and will be hopefully addressed in the future soon. There are many features of Bokeh that I will not discuss here, but you can check by yourself by clicking on those links. So now let's go to the most exciting part, in my opinion, which is how to do interactive plottings with this library. So again, we start by importing some stuff, the same as we did before, actually. And then I have to introduce you what a column data source is, which is just the basic way in which Bokeh handles data. It's usually required for doing any kinds of interactions, and it's very easy to work with. You just pass to it a simple Python dictionary or a pandas data frame if you prefer using a pandas data frame, but you're not forced to do it. And then things work as follows. So let's try to do the same line plot we did before, but this time using a column data source. So again, we import a column data source on top. We also import a column data source view, which is a way of just selecting a subset of our data. We also import a filter, which will be useful later. And first, we define the data, normally distributed in a Python dictionary, and we pass that dictionary to the data source, and that's basically it. We have our data source formed. So now we want to plot the figure. Let's do as we did before. We create the figure object, but this time we specify the tools directly via string, not anymore the default tools as had been used before, and we display the picture. Of course, the picture is empty because we haven't put any glyphs on top of it, although you can see already the tools that we selected specifically before. So let's put some markers on it. Here I chose to put some triangles. And the only difference between this example, which I will show now, and the previous example is that we're passing the source, the column data source, as an argument. And so we can specify the arguments of this call via the names of the variables that were passed to the initial dictionary on top. So X and Y, Bokeh is aware of this because we're passing it a source. Once the source is there, we have lots of flexibility, as I'm going to show next. So let's first create a view of this data set. The view is created here in the bottom. So you have a source. You pass the source to which this view will be applied, and you pass a list of filters. And these filters could be programmed in Python or in JavaScript. Here I'm giving an example for a filter in Python, a Boolean filter, which filters everything that it only outputs what has a value larger than 0. So in this case, we access the data in our column data source, the Y value, the Y variable, and then we output true if that number is larger than 0. Very simple filter. We again create a figure. We plot some circles on top of it. And by selecting one of many layouts available in Bokeh, you get the plot here in the bottom, which didn't work because I forgot to run something. Just a second. Yes, now it's working. So you can see that on the left, we have the original source. On the right, the view. And since here we shared the range, we immediately get some interesting visualization. You're free to play with this in the browser by yourself. And also, since the underlying data source is the same for both plots, we immediately get some selection tools that once applied to one side are visible on the other side as well. And this was done completely for free. So we didn't have to specify anything in particular to get this. This is very powerful. So in general, there are 3 ways of building some interaction plots in Bokeh. This one you just saw. But if you want to have more flexibility, you can use widgets. And widgets can be used either using a Bokeh server, which has to be running constantly and uses only Python. But I don't think this is very flexible because you need to have a running server for it to work, and it's not good to share. Or use widgets together with JavaScript callbacks, which makes it much more flexible. And the JavaScript required is quite easy. So let's get an example of how to do things with a JavaScript callback. There are many widgets available, some like drop-down menus and so on. Here I'm showing a button and I'm showing a slider. And these are doing nothing because they are not connected to any JavaScript callback. So now we would like to, for instance, change the size of our markers in an interactive way. So to do that, first we add a variable to our data source. In this case, this called size, which will be the variable that we will interact with from the JavaScript callback, because the interactions are only possible if the variables are stored in the column data source. And then we create our figure. The only difference now is that we are also passing size as an argument. And now the cool part. So we create a callback, which receives 2 arguments, just args, which are the arguments on the Python side that will be available on the JavaScript side, and code, which is the JavaScript code that you can see here. And then this callback is linked to the widgets using JavaScript onChange method. And once you understand this code, everything becomes clear. So you access the value every time the value of the slider is changed. This will trigger a callback, and you can access the callback in this way here. This is very similar to C. This parameter is the same as the one passed down here. That's why you can access the value. And then the rest is pretty straightforward. You just access the data stored in the source. The source is denoted by S since you passed the S as an argument. And then you loop over the data and you change the size of the marker according to the value of the slider. If you now plot the resulting plot, so you show first the slider and then the figure, you can now control very easily the size of the data points. Not sure you can see that via, yeah, now you should be able to see that it's pretty easy to control. You can play with this yourself. You can see how powerful this is because any variable that is stored on a column data source can be changed in any way possible since this is super flexible, right? And the amount of JavaScript code required wasn't too much. So I will now give you a custom example, maybe a bit more useful in general. which is a kind of a, let's say, a dummy exploratory data analysis. So again, we import all the stuff we want, and then we define our data. And here the data is just four kinds of variables, 2 exponentials, 2 Gaussians. You can think of this as, I don't know, the transverse momentum of your variables or the mass of your particles, something like that. And we pass again the data to a column data source here in the bottom. So very straightforward, we get our source. Now we're going to do exactly what we did before, but using a range slider instead of using just a slider. A range slider is a slider with 2 values. And we're defining this time 4 sliders instead of just 1. I could have done this in a loop, but I think it's clear for you to understand that 4 sliders are being created. And each slider will be eventually attached to one of the 4 variables that were defined above. So now they are defined, and we have to link them to a callback. So this is exactly what we did before. We're linking it to the callback. This time the callback, however, is very simple. We are only adding this line, which I forgot to mention before, is required to make sure the source is updated with the latest modifications you applied. So you look at this and you see that it's really not doing nothing. It's really not doing anything. It's just updating something that didn't get updated. So something else has to be done. And that's what I do in the next cell, where we define a custom filter. This is very similar to the filter I had shown before, the Boolean filter, but this time we are defining the filter using JavaScript as well. The idea is that the filter returns the indices that are only the indices that we want to activate. So we have a kind of a selection. It doesn't matter which kind of selection with the widgets we use. And then we want to return only the indices of the data points we want to activate. So I will demonstrate for it to be clear, a bit more clear. It works as follows. We define a variable called indices, which is just an array with a specific length. We access the start and the end value of our range sliders. We access the data that was passed to this filter as source. And then we just perform a simple loop over all the data source, where the indices will be true if they lie between the 2 values of the slider, and they will be false otherwise. Just that. And then this was defined inside a function so that we don't have to repeat code. I'm defining 4 filters here. And finally, I have to create a view which takes these filters, exactly as we did before. So again, it takes a source, and it takes a list of filters. Just that. Now we want to plot stuff to see if this is actually working. So the method you see here is exactly what we did before, but just inside a loop for convenience. We are plotting 4 different figures, one with each one with a different color, and using a different combination of the variables in the original data. You'll be able to see them in a second. And now we can plot the whole layout. And so what did we get here? We got nothing because nothing appeared. Just a second, maybe I forgot to run something. Let me run everything from start. I hope this works now. And it didn't. Let me try again, sorry. So this one works. So I'll have to just refresh the cell probably. Sorry about the technical problems. It should be fine soon. Anyways, there's a version available online in case this for some reason doesn't work. Yeah, okay, no problem. This is not working. I'll show you the example that comes next, which is very similar. It should then let me know if it works on your on Binder. It should actually. It has worked recently. So here what I'm doing after this is really much of the same. It was just a different way of doing stuff. In this case, I'm adding a variable called color to the data set, because this time I want to interact with the color. I could interact with anything as long as it belongs to the data source. And I'm defining that color to be gray. And then I'm just creating, again, the figures. And creating a new callback. You can look at this a bit with more detail, but the essential thing is that I'm changing the color of all data points selected to red. Simple as that. Let's see if this one works. So this one should work, I hope. Yes, so it's a bit slower, probably due to the connection, but you can see that all the data sources are the same. These are different views of the same data source. And once you select something on one of them, then the corresponding variables get selected in the others. If you hold the Shift key, you can do multiple selections, which is quite convenient. And so this just shows how much flexibility the whole framework has. And to conclude, there are lots of very cool examples by the community. You can check this. You can also create an interactive curriculum, for instance, online with all these plotting tools. And just to end with a small curiosity, if you really enjoy pandas and you like to do quick plotting with pandas, usually you do something like in this cell, you'd call dfplot method. But if you import the hvplot package, you can actually do the same and have Bokeh working as a backend. If the plot appears. Well, this is a bit slow. It's not working on my side. I hope it works on yours. It was working recently. Anyways, the plot you get should look quite nicer than the plot Matplotlib produced. So I'll end up here. And just before ending, I would like to show you this quick example. Since I mentioned in the beginning that Bokeh produces HTML files very easily, and you don't actually have to do anything. So what I did was just to produce Bokeh, to use Bokeh to extract the HTML file produced directly by Bokeh and just embedding the visualization directly on a website. This website was created with GitHub Pages, and you can see that it works exactly as in the notebook. And this one is working. So this was extremely easy to generate. In the repository, you'll find a different code with a more advanced example, which I used for a project of mine, and which it was also deployed online. You can see it here, and you can play a bit with it. This just to show that this can actually be very useful for some data exploration or display even directly online using HTML quite easily. So I'll end up here, and I'll take any questions if there are some. And I'm just sorry that this didn't work.
No worries. In fact, I think in case of something, just you will have probably your talk assigned to Python fundamentals in Slack. So I hope you could just continue there your discussion. Meanwhile, I think there is so many questions in Slido. So if you could,
oh, really?
Yeah. So it's good that you wrap up a bit before we could just take more questions.
Okay, let me open Slido. Right. So should I start from the one in the top?
Yeah.
Yes. Okay, let's start. So
yeah.
Someone asks, should I do it myself or should you select the questions?
No, you go ahead. You go ahead.
Okay, can Bokeh finally export vector graphics like PDF? If you need PDF specifically, I'm not sure. I know that exporting PNGs is very easy. If then you could explain why exactly you need PDFs, because then converting from PNG to PDF, you can use an external tool for that. But the main focus of Bokeh is actually interactivity. So in general, you'd want to have you want to share your plots online. That's why it focuses more on the HTML format. But if your question is only about exporting pictures, now it's very easy to do. Before, I admit, 2 years ago or 3 years ago, it was a bit cumbersome, but now it's very easy. Actually, if you can do it directly from the Jupyter Notebook by clicking on one of the tools. I hope this answered at least partially to the question. So the next one would be, is there LaTeX support in Bokeh? Is there like, so I suppose you mean for symbols? Currently, no. You can use Unicode characters, but as far as I know, LaTeX is still not supported, but you'd have to check. Actually, the documentation of LaTeX is pretty good. So if there's some, the documentation of Bokeh is pretty good. So if there's some possibility, it's there. But I think only Unicode characters are accepted currently. So the next one would be, I think interactivity kills reproducibility. It might be nice to explore the data with mouse, but scripting is superior and kills the argument against Matplotlib. it doesn't kill the argument, because as I was showing, even for basic plotting, I think Bokeh doesn't require to be interactive. So you can just specify no tools, and then Bokeh works as Matplotlib. It has the same features. Of course, Matplotlib has a bit more possibilities, but that gap is probably going to be closed in the future. So I don't think that kills Matplotlib Bokeh at all. And I'm not sure I agree with, I think interactivity kills reproducibility, because as long as you have everything well contained, you should still be able to reproduce what others have coded, right? It looks like plotter wars are the new editor wars. Ease of use is, of course, some of these have to agree to disagree. Of course, this is the whole talk was quite subjective. But I just think if you look at the two samples of code, I just think it's much more intuitive. Okay, but again, there's no way I can prove this. I just showed some examples. I gave my arguments. Probably there are also good arguments for Matplotlib. I'm not saying that one should rule over the other, but I'm definitely sure that people should be more aware of alternatives to Matplotlib. There's not only Bokeh, but there are also very nice alternatives such as Altair, which builds directly on the grammar of graphics, or Plot9, which is a direct porting of ggplot to Python. In specific, Plot9 has a syntax which is very nice. And people in general don't use these because Matplotlib is everywhere. It feels like a lot of boilerplate. Would it make sense to create a style API that uses Bokeh? Yes, exactly. That was what I would suggest. So Ben asked if we should do the same as it has been done for Matplotlib for Bokeh. I think definitely. I showed a tiny example at the end. Actually, it would be amazing if there was also support of Boost histogram to Bokeh. That would be super helpful, I think. And also some plotting tool like MPL-HEP, but Bokeh-HEP or something like that. If that's possible, it would be great. You don't have to create, so someone said you don't have to create a subplot or a figure. You're not forced to do that, but you're not forced to do that specifically for very simple examples. When you start to build more complex examples, then it starts to be more useful to use this object-oriented approach. And then you'll find online examples using different approaches, which can be quite confusing. Should I continue, or is this too much?
Let's take a last question, and then we will all move to Slack to channel to discuss leftovers of questions.
Should you then select the remaining questions so that I don't take one randomly? Yeah, for instance, yeah, just go ahead and suggest something.
What I left. What is your opinion on Seaborn and Plotly for data visualization? I think it's the most upvoted. No, there is other one, but yeah.
This is always changing, at least in my browser. So let me update.
I think our helpers, they are removing questions archiving questions that were replied already. Okay. So no worries.
So I'll answer to the one which is not anonymous, maybe, by Matthew Factor.
Okay, yeah.
Which asks if it has a hardware acceleration backend for intensive graphical simulation, or is it more focused on interactivity? As far as I know, it's focused on both. So you can specify WebGL as an acceleration backend. And if you really have lots of data points, usually this starts to be a problem with around 100,000 data points or so. You can either improve your JavaScript code in the callbacks, because it can make a difference. And if it still doesn't work, you can use higher level libraries such as HoloViews, and specifically data shader. I think it's called this way, data shader, which is specifically done to handle very large data sets by just rendering parts of it. And then each time you interact, you trigger a callback, then it just focuses on a new subset of data. So it's also a nice alternative in case you have really huge data sets. And the examples they have online are very, very nice to look at.